Alright, time for another draft science video presentation. Alright, we'll do a comment and see where else we go. Alright, so there are so many. This is Scott Steffen, two first names. Anyway, trying to cause some discontinuity. But anyway, there are so many different ways people do physics and even names. But anyway, much of modern physics seems based on math first with logic filled in later. I'd say it's both ways. I'd say there's just as many examples of them, contriving math to fit whatever their theory is, and it's just contrived. You could, just go to this whole whatever living force nonsense, the 1/2 mv squared formula that was for 100 years wrong, and then they made it less wrong, but it's still really wrong, and it doesn't really make any sense. It just breaks the whole concept of momentum and conservation of energy because it creates magical energy out of a bizarre reformulation of a notion of, for example, acceleration is, you get half the distance, you get half the velocity for your acceleration in gravity, for example. So the first initial progression in your gravitational fall, you only move half the distance that gravity would say you should be moving through acceleration. And that half ends up becoming a square of your velocity when they invert the equation to go the opposite way. I suppose that's one rationalization for it. Because they really couldn't say, half the mass and 2 times the velocity, because, well, that would be exactly opposite, right? I mean, the half and the 2 would just cancel out and then you'd be back to mv. But it clearly doesn't work. It's clearly nonsensical. It clearly just doesn't make. It's overtly just sitting here saying to you, this is wrong. Something's wrong. I mean, either mv is wrong as momentum, or 1/2 mv squared is wrong as kinetic energy, because the two things really can't be different when it doesn't have anything to do with hiding potential somewhere. There's no hidden potential somewhere. When a bullet is speeding through space, there's no hidden potential energy anywhere. Okay, it's all kinetic, and there's just no good reason to think a bullet half the size, that I give twice the velocity to, has 4 times the amount of energy. No, it doesn't. It will not heat more things. It won't do any of these things they think. It's not free energy. You can't gain free energy this way by slicing off weight and increasing velocity. You can't increase energy that way. And physicists should know that. I mean, I should have to explain this to them? So anyway, it's just obviously crap is what it is. You can say all this other stuff, but it's just crap. Okay, in fact, sometimes the complexity of the math, yes, that's the other part of it. Make it so complex that nobody can fact check it, nobody can do any logic on the actual equation and say, well, this part doesn't make any sense and this part doesn't make any sense. And they never, ever, really, ever solve any of these equations. I've never seen anyone show me how they mathematically figured out the precession of Mercury, okay, the parallelium or whatever. Never seen the equation actually finished, actually completed, actually proving Einstein right. Never seen it anywhere. And I could go through the list of all these, even when they do the 2-slit or anything, they just sit there and give you this silly formula and say, yeah, it gets the right answer, no problem. They never show you it getting the right answer. They show you in a vague way. Oh, well, let's do 7 inches, close enough, right? 6, 7, 10, it's all the same, right? We don't need to do any of that 10 million decimal places. The only time they get anything specific is when they're telling you the mass of something nobody could ever put on a scale. So nobody could say, oh, no, that's wrong. My scale says this. There's no way to fact check anything they say. They just tell us that, well, we've decided this is what it is. It's just terrible. In fact, sometimes the complexity of math hides the fact that the theory makes no sense. Yes, obviously. I enjoy your approach to physics. Yeah, my approach is just to look for something called the truth and to see if somebody actually has evidence to back up their argument of what they're saying the truth is. And it's really bad evidence when you have a two-source experiment, that's completely explained by something simple like, well, it's just radio jamming. And they come up with this whole preposterous theory that breaks all of the common rules and makes us have to believe in something that's just kind of silly to believe in. And again, like light being bent by gravity. Well, it makes absolutely no sense in the context of every other single experiment ever performed on any of these forces. It seems the forces really just don't like to interact with other forces. So how come in this special circumstance it interacts? And not only does it interacts twice as much as would be the realm of possibility even, of a good guess of how much it would be interact. It's interacting in this bizarre manner that makes absolutely no sense. And yet, that's good physics. Alright, physics, and watch your videos because they seem based on logic and rational explanations. And some scrutiny. I have applied some scrutiny. I've sat there and actually scrutinized their evidence to see all these huge, gigantic defects. You had to go through it word by word and say, is that true? Is that what the experiment actually shows? I couldn't find that. When I looked at the experiment, I couldn't find that thing happening. All right. One of the worst quotes I've ever heard about physics was Neil deGrasse Tyson, who's just a clown. He's just the Barney the dinosaur of physics. I mean, his physics is so lowbrow. It's just, hero physics or something. Said the universe is under no obligation to make sense to you. Yeah, he contradicts himself all the time. 1 minute life just poofs in the universe all over the place. The next minute, oh yeah, it's too hot, too radioactive, too horrible a place, the universe, too inconsistent for there ever to be life developing anywhere. It's so rare, forget about it. I mean, he'll say those two opposite. He'll make those two opposite arguments. I mean, he lands nowhere, But yes, of course it should make sense. I mean, it's just idiotic. Of course, if you have the right answer, there's going to be a logical, you're going to sit there and say, oh yeah, that's perfectly reasonable. Like I say, if you ever find out what the origin of an electron is or a photon or whatever it is, it's not going to be a fun answer, but it's going to make sense. You're going to say, oh shit, why didn't I think of that? All right, one of the worst, no obligation to make sense to you. And a truly correct answer in physics will make sense. Any truly correct answer in physics will make sense. Yes, it is a mechanical system. Even evolution, there was parts of it that didn't make sense. I mean, I'm sure, back in the day, when they had to argue this stuff, based on a smaller pile of facts, it was a problem, the missing link problem, right? Well, why aren't there any, transitional human fossils? How come you have so few of those? How come they're so rare? How come they're so not existing? How can you have this theory of evolution when you have all these missing pieces to your evolution? And then the logical theory came along that first, there's more evolution in small tribes that inbreed, and clearly there's going to be more evolution in anything that separates itself from the herd. You're not going to be able to evolve if you're a herd of 10 million buffalo, for example. You're not going to be doing any evolution because any aberration, any white buffalo that pops up, he's going to be turned brown again. Okay, he just isn't going to really have a choice. He's not going to be superior enough to dominate the gene pool. He's not going to be able to take over. He's not going to have magic, radar eyes or something and be so special that everybody, breeds with him and everybody gets polluted by his genes. It's going to happen the other way around. He's going to get diluted into nothing. And these are just obvious explanations. And they're all going to exist in physics too. There's obviously sensible explanations that are going to sit there and answer these questions, and you just don't need to jump into this woo bucket. That's the first course of action for these nerds. And let's just call them what they are. I mean, they're usually obsessive, nerdy, weird people. Okay, frankly, they're quirky, right? They're quirky. So they go for all this, magical, live in some sci-fi world kind of crap, and they're looking for magical answers. They're not living in reality, these people. And so, of course, they jump to any excuse to jump to the magical solution. They jump to it. They're just as bad as the woolly religious kooks looking for magical answers. Ugh. All right, anyway. A truly correct answer in physics will make sense from the smallest of levels to the largest of scales. And again, there really aren't any, right? There's only one universe, so any description of the universe is going to have to include the smallest stuff, because that's the stuff making everything happen. So if you want to explain how a galaxy works, you're going to have to explain that, well, gravity's a nuclear force, and it's really just moving a bunch of electrons and protons. The correct answer is going to come from the small universe, not understanding the big universe. But anyway. One of the fundamental explanations in physics, the two-slit experiment, is so misunderstood that some of their explanations border on magic. They don't border on magic. They are magic. They're clearly magical. They can't be duplicated in any other circumstance. They can't possibly find any other way to make this phenomenon of interference happen with any two forces. They can't do it with light in any other circumstance. They can't do it with microwaves. Can't do it with radio waves. Can't make it happen. And they force it. Like I said, in the two-source experiment, they have absolutely nothing to cause the wave function. So the two-source experiment, the radar experiment, is basically saying, no, we're going to take two light beams and crash them into each other, cause interference, and the light's going to make a pattern. Well, that's not realistic. We know that doesn't happen. So why are they saying that's the correct answer? Again, the obvious answer is you're just jamming the signal. I mean, obviously the energy's still getting there. You've overlapped two radio signals, and when you overlap two radio signals out of phase, you can't make a receiver on Earth without a directional antenna or something that can decipher that. It can't say, oh, I can see there's two things here. Okay, there's not four, there's two. This two and this two. It can't do this splitting of the signal and say, oh, I see the real signal in there. No. Yeah, no. All right, anyway. Borderline magic. You've obviously put a lot of thought into this subject. Yes, 10 years of pretty obsessive sitting there having to look at it over and over again to find what were rather obvious defects. I have to admit, it should never have taken me 10 years to see the obvious. I mean, some of them I had them. I had them 10 years ago. The whole idea that it's a circle, that you have to recognize that even the math is telling you there's one distance, there's one radius of the distance to the target, and so you're really mathematically predicting the pattern on an arc. So I knew that 10 years ago that was the right answer, that it had to be looked at as an arc, and then I just sort of let go of it because I wasn't getting anywhere. And I should have realized that arc means it's all there's only a finite number of fringes, and it's all in a container. And, once you realize that, it's all being contained, then you realize, this is too simple. The number of wavelengths inside the distance is dictating exactly how many fringes there are. There's no mystery here. There's only a certain number of wavelength differences that are possible in the distance. So why is this made a mystery at all? There's no mystery here at all. It's so mechanical. But yeah, it took me 10 years to decipher through all their rhetoric and all their mush and all this inundated with it has to be, it has to be, it has to be, it has to be. And you just lose sight of, no, it doesn't have to be. I guess it's part of it. You just really can't believe they're this dishonest, this propagandist, this unscientific. You just didn't realize that these scientists who you thought you had some respect for because they seem to know a lot of shit, that they really were just full of shit and talking shit. They just made this crap up. Again, 1/2 mv squared. You look at the history of this stupid equation is retarded. It's obviously not a real scientific equation. It's a garbage equation created under garbage circumstances. It should have never been embraced as physics. Ugh, the living force. Fiddle faddle. Anyway, just so bad. All right. Explanations born on magic. You've obviously put a lot of thought into the subject, and your explanations of the two-slit experiment is logical, straightforward, and makes sense to anybody, and makes more sense than anybody else's. Yes, it certainly is. Well, it's grounded in just defining some just so obvious truths. I mean, again, the jamming argument. I shouldn't get any award for pointing out that. Well, isn't the geometry for jamming a radio signal exactly the same? I mean, is there anything different I would do in the math to prove jamming? Oh, there isn't a single thing I would do different in the math to prove jamming. So why are we jumping to the crazy answer when the simple one is just sitting there saying, I'm the right answer? Again, momentum, mv, okay? Mass times velocity. It's sitting there just saying, I'm so simple you can't miss me. And yet they had to screw it up. They had to say, oh no, it has to be 1/2 and we have to square something and we have to make this convoluted and stupid. We have to make it irrational because it's just way too simple and way too rational. It makes the universe too obvious. MV, oh frickin', how are we going to make our free will out of MV? How are we going to make our magical, exploration of the, Star Trek universe out of MV? Oh, that's not going to get us a warp drive, MV. No. It's just so bad. Oh, it's all so depressing. Anyway, I cringe every time I hear one of those so-called big names in physics say that a particle will change how it behaves if it knows a human is. Well, unfortunately, most physicists aren't that bad. But there are a percentage of them who are buying into this mushy observation. We observated it. Whenever an observation, yes, it has to do with my personal experience. I personally observe, and the rest of the energy in the universe is not an observation because it's not connected to a human being. So any photons that don't go into pupils, they don't count. They don't cause wave function collapse. Only the photons that go into eyeballs will have something to do with collapsing things. I mean, it's so bad. I mean, it should be like a Trump crime. I mean, it's so bad a crime they're committing against logic and reason. All right. Oh, it's just cringe. There's so much that's so cringeworthy in this world. All right. Particle chase how it behaves human observing. My question for you. Oh, good. Is about the whole wave versus particle thing. Yes, well, particles can look like a wave, but they're still not waves, okay? Even when they're looking like a wave, they have nothing to do with being a wave. In sound and in water, okay, waves are created because the molecules are either being forced, okay, by compression to interact with each other, or, in the case of water, they like each other and they're glued to each other. So if one moves, all the other ones move too. There's nothing like that in the real physical universe. Nothing does that, okay? The elemental particles aren't anything like sticky molecules. Nothing like them at all, okay? They're not in any way can they ever connect to each other or reject each other. They just don't play in that universe. All right. Okay, particle thing. Is there some kind of connection? No, there isn't. That a photon has with the photon before it and with the photon after it. Yes, the connection is they're at a frequency, okay, they're going to cause effects. So it's the tipping point argument. Of course, there's a connection. I hit something and I move it. It starts rocking, and then I hit it again. And now I move it, rock it more, even more. And then I hit it again, okay, at the right moment in time. And then I tip it over. Okay, so clearly the first piece of wind that moved the bridge, and then the next piece of wind that moved the bridge, and the next piece of wind that added energy to the bridge, and the next piece of wind, a little gust, the little gust, the little gust, the little gust, and then the bridge breaks. So yes, they're connected, but they're not connected in any serious way. They're just connected in the way resonance frequency is connected. So they're connected like the vibrations on a string end up becoming a big loud sound that comes out of the violin. They're connected in the sense they've been added to each other through a mechanism, but that's it. They're not connected in any other way than the fact that I could have something at a frequency and I just put two boards, doubling the distance is the same, and then I could bounce stuff off the backboard into the front and it's coming out as if it reflected off the other board even though it didn't. That kind of thing. They're just adding, okay, because they're being synchronized. So yes, they're synchronized by the thing they're hitting, and by being synchronized they can now cause a much bigger effect. All right. There's some kind of connection with the photon with the photon before it and the photon after it that gives them some wave-like property. So it has nothing to do with a wave-like property. The property might be a definition of something that becomes a wave, but the property is the more elemental thing. Okay, the wave isn't the elemental thing. The fact that you can have synchronization is the elemental thing. Okay, and the fact that that can look like a wave, fine, but that the wave isn't the elemental function. The synchronization is the elemental function. Not a physical connection, right, but something that gives a chain of photons different properties than a single photon. So again, I've sort of made that clear, so I'm surprised you would even ask the question, in the sense that clearly I'm arguing. I haven't used the word synchronization, but I have used the word resonant, and I have used this tipping point thing so many times. So obviously their connection is circumstantial. Okay, they all visited the same hooker, whatever. It's circumstantial, right? They're not really organized, but they all did something in common. Obviously there's no frequency without multiple photons. Well, again, it's not photons, so again we're stuck with this stupid photon word. I personally love the word photon, a very cool word, but it's so misunderstood in the sense that a photon is a description of a bus, okay, with people in it. It's not a thing, okay, itself. It's a description of a function. A photon is a function. All right, it does happen over time. It has pieces and elements to it. It has properties, where it's polarized. It's a book. Okay, it's not a page. It's not a word. It's not a character. It's a book. Well, a book is going a little too far, so maybe it's just a paragraph. But it's a paragraph. It's a structure. It's not something not made of something. A photon is made of energy. So, you call it energy-ton. I don't know. They're all the same thing is the key thing, right? We know that the radio wave is a photon. It's not a wave. They're photons coming off the antenna. All right? Most physicists will say those words. They'll agree with that. Yes, they're photons coming off the antenna. Okay, yes, we call them radio waves, but they're not radio waves, they're photons. And photons are more complex than just saying rock. Obviously, there's no frequency without multiple photons. So again, it's not photons, it's multiple quanta, the bits of force, however you want to describe it. But yes, there has to be things at a frequency. Okay, I know you said that photons are composite objects, right? So that should be good enough for you right there. That should say all that needs to be said. They're made of more than one thing, and those things are at a frequency. That defines the properties of the photon. How far are the seats spaced? That's the photon. Is there something in their composition that entangles? No, nothing entangles anywhere. Entangle is just horrible, not the best word. Yeah, no, it's not the best word, it's the worst word. Don't even think about that word being part of anything to do with reality. It's just baby. That's a baby talk word. That's like a whatever. Neutrino. yeah, forget about it. Okay. Entangles them in some way to make them more than just a grouping of matching individual objects. So no, you force them to be synchronized. Okay, because an electron moved, it's synchronized some elements of the universe. It's being synchronized by the movement of other objects that are forcing things that were way disconnected to being more connected in terms of their motion. And that's about all you can say about it, is that the matter moving changes, how the force interacts, and those movements can be synchronized. Like when you put electricity through the conductor and you cause a bunch of electrons to all move in a synchronized pattern. All right, well, that synchronized pattern gets imposed on the force. And now we call that force photon instead of gravity. Instead of it just being gravity, instead of it just being the stuff that's crashing into everything all the time in some random way, it's now turned into clumps. And the clumps can do things the non-clumps can't. Are the vibrations of the photons matched and in sync with other photons from the same source? So again, if you're just understanding it as energy, little things much smaller than photons, and a photon is just you creating a pattern in the other stuff. So all you're doing when you make a photon is you're creating a pattern, a specific pattern, okay, by compressing or expanding how the force is moving, what space it's moving in. I appreciate your thoughts on the subject. Okay, well, I guess that's all. So yes, I gave you my thoughts on the subject. Let's see if there's anything else I can do with that. I guess not. I mean, I could go to the drawing board, I suppose, but I think you already know those answers. I mean, I really don't need to draw another photon, do I? I mean, it's a little ball, little ball, little ball, little ball, then it has a polarization somewhere in that, and that's a photon. Whether there's 2 of them, or 3 of them, or 4 or 5, open question. It can't be really, you can't really imagine it being too many, in this. And the trick is, too, is that they're always created in pairs, so I guess you could argue that's another piece of synchronicity, is that when an electron moves, it's not synchronizing it's making one of the clumps of the frequency, right? So there could be 3 bits in that clump, and then that clump is separated by a distance to another clump of could be 3, could be 4, and then another clump that could be 3, could be 4. So in a sense, the electron is not making the whole photon, but it's making more than one. It's putting in the ingredients to make 6 cupcakes, right? So when it moves, the electron moves, it puts in enough flour for 6 cupcakes, right? And then another electron has to do it, and that creates the sugar, So each one's putting in the ingredients of the photon, but the photon itself is not going to be made by one electron. And that can be deduced out of the fact that the polarization of the photon is gigantic. So there's just no way that one electron did it. One electron can't make something go this way really large and this way really large. There's just no practical way that you can say one electron did that. One electron made something go this way really large and this way really large. And this way stays the same. This distances don't change. Okay? So neither of those distances change. I mean, you could sort of argue, well, if it went in a diagonal, then it could send energy this way and it could send energy that way. But that energy would keep spreading, so that wouldn't make a photon, would it? No, it wouldn't. All right. Yeah, really. This is if I only knew 10 years ago, I just had to do this. All I had to do was do this. It's the inverse square law first. You can see that kind of obviously, right? Half the distance, 4 times bigger hand, so. And this, it's just what happens when I do this. What am I doing? what happens to all this stuff between point A and point B? All this stuff that might be here. If there was a bunch of little jelly beans here, what would happen to them when I did this? And what would happen if I do this really, really fast? You know, it just tells you the story that this is all you need to do in the universe to start synchronizing things and start creating patterns. That's all you need to do, is that. And that's all the universe is running on. It's so simple, a mechanical system. Forces matter to move. And then when the matter moves, it forces the force, you know. It causes the force to compress or expand. And that just always has it just keeps, every bit of movement is connected to movement. You can't disconnect the movements from the movements. So that's why things can look like they're entangled, because this moved over here and then surprisingly this moved over here. Well, it's not that surprising, because it does take the speed of light. It does take a long time sometimes for it to actually happen, but that's what's happening. This moves, this has to move, because this did something to this, okay, and that change is going to be affecting that thing over there. That's all. No wooey action at a distance. Alright, probably enough. So we'll do some D. Hilster. So he stole poor old Franklin's show, because now he's not even interviewing some big earth dork or some infinity dork or some, some other idiot dork. All his theories are he just ruins. He's got the particle part right, but he ruins all of it by just jumping on all these flat earth bandwagons of nonsense. And he thinks because the one kind of physics, anyway, he's just replacing bad physics with garbage physics, which is just ugh. So we'll go to the Chappelle version. See what he's up to.
We then, in special relativity, take and say, boy, the math that we have, the frames which we artificially throw into the universe, and we put negative numbers on, because there's no negative numbers in the universe, but we do that anyways. Then I throw a frame on a train and a frame on a guy off, next to a train, and then I start doing the mathematics between them, and I see the symbology gives me some kinds of relationships of being able to calculate. All of a sudden, to when I throw the philosophy of, you can't go faster than the speed of light, and all frames have the same physics, all of a sudden I get these bizarre mathematical conclusions that
yeah, well, why don't you draw it? Okay, why don't you draw your theory, because it's just as bizarre. You have stuff going double, the speed of light squared. You have magic functions in the universe that somehow we're totally unaware of. Even though there's absolutely no way we could miss it. There's absolutely no way that if there was something moving twice the speed of light squared, that somehow evolution wouldn't have taken advantage of that. I'm sure the snakes and the rats and all the other organisms would have loved to capitalize on this, knowledge they could have had ahead of time. They could have known, twice as soon what was going to happen. Not even twice, right? The speed of light squared. I mean, almost instantaneously, they could have known something was going to happen. Yeah, they'd love to take advantage of that. Well, anyway. So let's jump around and see. Well, let's know. He always starts with the boring crap. I mean, well, this is what our website's about. This is what we're thinking. This is what we're hoping. These are the dorks that we have in our group. Blah, 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 blah. Over and over and over again. Just make one video that is an about page, right? You don't put the about page on your home page on every single page. You don't put the about page. Here's the about page again. Here's the about page again. No. You make a separate page and you tell people, are you interested in who the fuck I am and what I'm talking about? Well, here's the about page you can go to. I guess I should make an about page. Cranky motherfucker page is what it'll be. Sick to death of you stupid fucktards. Just so sick of the stupid fucktardia that exists on this planet. Page. That's what it'll be. Anyway. Yeah, he's still doing it. all of this. Oh, who's this wacky guy? Coming in 2001, Stephen Bryant, who believes that your anus twitches are controlling Mars's orbit.
Will be definitely this year. We're looking forward to him. He pops on here once in a while. So Steve, very interesting person.
Yeah.
He has agreed to talk with us, come on and talk about his book. I think he's got
Disruptive.
another version of his book or another edition of his book coming out or whatever. He's saying he's waiting for something before he does that, but that's okay. We can wait, but that will be definitely this year. We're looking forward to him. He pops on here once in a while. So Steve, if you're there, hey, let's set that date up soon.
All right, sorry, I shouldn't ridicule without even knowing anything about him. I mean, it's perfectly rational to disagree with relativity because it's idiotic, and Einstein even knew it. Einstein proved his own theory to be bullshit when he did the thought experiment with the photon, the light clock. The light clock destroys Einstein's whole theory, goes right down the toilet. Right, so it's destroyed by his own thought experiment. And it was just his juvenile musings. Okay, this whole theory was just, he was young and whatever, silly, and so yeah, he wrote some silly papers. Next to the papers that make some sense, he wrote some silly shit.
Coming in January. My graphics didn't change the graphic there, but it's coming in January. It takes a while to get these people.
So this Unsucker guy just seems like a huge bigot. I mean, if he is a German physicist, he don't like him much. Okay, that's all it comes down to. He loves all the wacky Duraki crap. Wacky Duraki. Oh, I love that. Okay, so accidents. Some of them are really good. So wacky Duraki, all the woo physics, Einstein. All that's great shit. Great shit. And anybody who is a rationalist is evil. But anyway, I mean, not that you can compare. I mean, all the physicists are idiots, but I mean, he's got a very skewed view of how to define idiot.
And get them lined up. So he is still on board to be
very exciting.
He hasn't put one up for months and months, but he's got lots of them. So just like we watch all of you people who are stuck because of COVID.
Nick of Time. Yeah, this is the guy who thinks time is infinite or something. I don't know what the hell it is again. I forget already. Nick of Time. Yeah, sure.
Squared. Boy, there's a lot of interest in C squared. Sorry for the pixelated.
Yeah, well, he just bailed out anyway. He just made a video saying, I ain't going to make videos anymore. Bob, you really only have this much time left. I mean, I have this much maybe. We all be drop dead tomorrow, and it's just the odds. We're rolling the dice, and, the dice just have terrible numbers. And so, I think you ought to just say as much as you possibly can, because I don't think you have all that much longer to say it. But whatever, just my impression. There's always more to say, I guess is the point. Yes, if it's occupying too much of your time just to muse a little bit once a week, well then, don't do it. But, I don't think it's that arduous a task. I wouldn't be doing it every day, if it wiped me out. But anyway.
Of course, the energy wave theory, Jeff Yee, haven't you got to him? He's over 2,000. Nice graphics, Jeff. Who made your logo? Pat myself on the back.
Okay, that's your logos are really important. Shit, you got to concede that that's really 90% of the work here is to have a good logo. Oh no.
We're not doing. I said, Nick says, well, again, I've done videos for a long time. So that people.
So he's just doing this same review of these same fucktards over and over every week. The same fucking thing.
And everybody else is wrong.
Did it again.
Then why would anybody want to read your work, or why would anybody? How would you have
look, this is me
right now? I have a great admiration for anybody who is willing to stick up and
anybody who's willing to storm the Capitol building and wear silly hats and they're all good Americans. No, they're not. They suck. You've got just a collection of cranks and crackpots who are so arrogant, they and they have no discipline in how far and how bizarre they're going to get. They just make up a ton of stuff that just can't be argued as being reasonable, just poofing, and a bunch of poofy powers. And it's just, what use is it? I mean, they're just changing the labels on the wacky behavior. They're not explaining any of it.
Their heads out and their necks out and say, hey, I think I have a better way to look at the universe, and here it is. But support each other, folks.
No. Only support people who produce evidence, okay? Who sit there and draw you the picture. If they're not drawing you a picture, forget it, okay? That's the first rule. If they can't draw it, it ain't real. It ain't sensible. Because when you know it's sensible, you draw it. That's your first impulse. Just, hey, I'll draw it.
Okay, let's keep moving along here. Get to our slides today. I think we're going to be there. Yes, science, poetry versus physics, reality. Now, I think
90% of the people in this group just use science poetry. They just, they have all these weird words, for that religious guy, the spiriton or whatever, solitons. They're just making up this crap, and it's horrible.
I don't remember who it was. I don't know, it was Bob Gray or James Keane or somebody said the word science poetry, and I told them on air. You can go back. So I'm going to steal this. It's really pretty much that. It's science poetry versus physics reality.
Well, even their math, like I say, has this poetic crap in it, the living force, and then they just write an equation that's completely irrational. It just says right on its face, well, you have to break everything else because we've written this new equation where somehow velocity is squared and the mass is 1/2. Yeah.
I mean, we hear a lot. That's what it looks like to me when I see people in the chat and they go, I think the universe is full of energy and it's this and it's, I can't even come up with them myself. But when
yeah, it sounds like one of your average members. There's an etherton, and the etherton spiritualizes in the circular wink wonk and does the honky donkey wonky bonk. And after all of that happens, there's a bunch of dirty bed sheets, and somebody's got to wash them, so they put them in the Oonka Doonka washer and the Pinka Pinka Bonka. I mean, it's just crap. Well, just blah, 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 crap I'm making up, blah, 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 blah.
I look at them and I see these phrases. It's a lot of words. And I'm thinking to myself, I'm tired of words. I've been around physics critical thinkers since in my early 30s. I'm now 61, so I've been around 30 years. Great thinkers, and I hear lots and lots of
right, and you've been impressed by absolutely none of it except for some wacky guy in South America or something who's got you believing in infinities and whatever, tinky donk all the way down.
Of words, and I'm tired. I said, well, what does that mean? Oh no, it's just I don't care what it means. I mean, what do you ask me that for? But here's my system, and it's got energy and dipoles and fields and charge and
yeah, that's what yours has. Nothing in it. Okay. Oh, there's no charge, even though charge is a real phenomenon, a real thing that happens in the universe. You can't deny its existence because it's so frickin' elemental to everything that happens. But I'll just say it doesn't exist, and therefore I don't have to explain it. I mean, you're as wacky as the best of the wackies.
I go, well, what's charge? Charge is a fundamental thing. What are you talking about? The problem is the general public is the same way.
There's about 7 zillion tons of the evidence that it exists as a phenomenon, and the idea is you're supposed to explain why the same field, okay, the same clump of little stuff. I can just make a little circle around the same ball of crap. I put this little ball of crap here, and I put an electron there, and it goes speeding, flying into it, and I put a proton there, and it flies away. You have to explain that. You can't just sit there and say it doesn't exist. The same exact conditions are causing the two objects to do completely opposite things. That's not a nothing phenomenon. That is a substantial phenomenon. That's like one you really have to explain. And you just cop out. I don't like the word charge, so I'll get rid of that. Now, next I'll get rid of magnetism because that's annoying too. I don't have any explanation for that, so let's get rid of that slop. You know, they have a vague, his theory is some vague notion of, if you spin things this way, and then in water, the water will make the stuff down here go towards it, and make the stuff go away from it. That's their vague notion of how the realities work. And so the magnet, all the time, is the magnet's doing all this work. There's all this stuff, swirly, burly, swirly, 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 swirly. It's rowing and rowing and rowing and rowing and rowing. Even though it's a little magnet just sitting there, it's doing all that work. Yeah, I don't think so. I don't think it's turning the waters. So, and he's a particle guy, and he's talking basically about just turning the waters. Row, row, row your ether. Oh, God. So bad.
Where I'm at, they're just tired of it. And I see that, thank you, Franklin. Franklin says, that's James Keene, inventor of science poetry. Okay, James Keene, thank you so much. If you do nothing more in life, you've no, I'm just kidding, James.
Yeah, whatever. Oh, please get to a real subject of some kind.
Well, the only good thing I can say about that before I bring somebody up who can raise their hand, and if you're in the green room, put your camera on, raise your hand, please, or make something. I do want to keep this discussion-wise. It's a lot more interesting, of course.
You're so much better than Franklin. Yeah, I mean, okay, they just drone on and go blah 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 a lot, but geez, this is better. No, don't think so.
But I will be watching the chat as well. But I honestly think there's two things I would say about this. I say, most people talk science poetry.
So there we go.
They talk lots of words.
There's somebody bringing up Leibniz. So Leibniz is responsible for this stupid living force horse shit. So what's this asshole saying? J. Bonksovich was the first in the history of philosophy to combine Newton, Descartes, Spinoza, and Leibniz's method of thought in the middle of the 18th century before Maxwell-Einstein era of physics. Yeah, exactly. So he started this whole relativity mishmash. Let's just invent, spirit energy. Oh yeah, great. Yeah, this is terrible. I mean, this whole mixing of philosophy and science anyway is just kind of disgusting. The physics is looking into one aspect of reality that just doesn't have anything to do with human fun and human ego, human anything. It doesn't have anything to do with your gods and your woo.
Systems, and the systems all they're all logical, and that was, that's all really great. But when you try to pin them down and say, okay, you're talking about energy and energy fields and all kinds of stuff. We're gonna go through
fields of energy. Yeah, there you go. Like fields of birds or something. Yes, the field is made of stuff moving, and it can have more stuff or less stuff, or it can be moving in patterns. But that's all you have. That's all you can do to it.
Some words, but I just wanted. What I'm going to try to do is I'm going to try to keep people on topic here, because we are going to talk. I've got a bunch of words we're going to take a look at today that are also problematic, that people use constantly.
So after 58 minutes, whatever it was, let's see, 39 from 1. Okay, so after a half an hour, you're finally going to get to saying something.
And we don't talk about what they are. The good news, the other thing I was going to say is the good news on all of this is that the current models that people are truly pursuing quite a lot today, the more modern models, which I would say are in the last 5 years, we've had models going for quite a while back, or at least
what the fuck? I don't even know what he's talking about. The last 5 years? Whose model is that? Where's the last 5 years where all these new models popped up? Anyway, I'll jump ahead, see what this dork says.
Particularly if they do not use mathematics. And the reason for that, I look at mathematics as an extension of the natural languages, and it allows the natural languages to express.
Yeah, right. But it just to give the language to a moron and they turn it into garbage. Okay, and we see that in physics they can't even use words rationally. Wave doesn't. I mean, they say spin. It doesn't even mean spin. So what good is mathematics if they could do the same thing to actual words? That is, they could just, you know, strange quark. I mean, do stupid things. They don't, you know, it's a totally idiotic description. Well, why don't you think they can do the same thing to the mathematics? And then you end up with 1/2 mv squared. You end up with some idiotic formula that can't possibly have anything to do with reality. You know, and they say, "Oh no, it's real energy." You know, except you can't use it. I mean, you'll never test for it, and you'll never see it, and you'll never do anything. But it's real. Yeah, it's real. Because we say so. Anyway.
If you subscribe to infinity, that is, there are no partless parts, there's always something below that's going to be making it up. Are we going to be able to, how far are we going to as human beings go down below to find those things? Probably not that far. So
Why? What's the limitation? Just like what's the limitation to seeing farther? There's no limitation, no real limitation. I mean, you know, it's just a technical challenge, and that's it. So this infinity crap doesn't go anywhere because it's already kind of decided and it's shown that things change with distance, and the small universe isn't a duplicate of the big universe. The big universe is an emergent function of the small universe. It's showing you some of the simplicity of the small universe because the big things are doing simple things, and we're the only complex level. You know, a few little chemicals on the surface of these orbiting balls of shit are doing a few things that are a little more complicated, but you know, realistically, all the other levels of the universe are just doing really dumb things, simple things.
what level you're on, you could be levels way down, you can have the same thing going on. So it's just a classification. So
The Horton Hears a Who theory. It's a nice little kid story, but you know, come on. Oh yes, physical reality. Yes. There's little people living on the dust. No, there aren't little people living on the dust.
in the particle model that my dad and I are working on, and we have a part in our book that talks about that. What's its predictions, and can you measure it? And we have actually a my dad bought
Well, he bought a Hoobie hat and you know, a Von Trunkel and a Von Stinkel, and you know, you know, what, you know.
a volt machine that goes to point what 7 digits. I think it's used in astronomy, but it's super accurate. So you can measure things that people weren't looking for. And yeah, there's mathematics for that. So I think I don't think we're in disagreement here. We're talking about different things. So when you made the broad sense of mathematics is something that is, you better show me the mathematics behind what you're doing. I'm not sure. Maybe that's not what you, in the end, we're meeting.
Yeah, look, the functions are kind of yes and no. I mean, so most of the mathematics is, in fact, elementally correct. I mean, we can deduce the speed of gravity. We can find out some of this stuff, and it has mathematical. You're not going to change that crap. So why would even anybody talk about that? That's not the relevant part. The mathematics for jamming is the same as the mathematics for wave interference in the two-source experiment. Same exact mathematics. So how's math giving you insight into the truth? All right? It really isn't. This is about causes and effects. Okay? And the math can help, but it's not going to give you perfect vision. It's going to throw lots of things in your way that are going to seem like, well, that doesn't make it look. I mean, the mathematics is saying that light is bent twice as much by gravity. Well, where, did you do that experiment over and over again? No, but you all tend to believe in it because they told you so.
I think it's more clear when you say the mathematics better be, can be applied to your model to do useful things and do calculations.
Oh, you're done with this.
To define an electron. I see.
Right. Right, right. And that's one of the things that bothers me, and that's one of the things that bothers my father and I constantly, is, for instance, I mean, if you look at Coulomb's law, for instance, you have charges, and no one tells you what charges are. There's no force there. You have no idea. Well, we have a real mechanism below it. We say anything that curves in the universe is from a random gravitic field, whether or not it's, something like would be the electron, we call electron photon gravity.
Yeah, right. So the force that you still haven't explained. Okay, so where's the gravity field come from? What's causing that? So you can't explain it. So you just make up a fake. Well, there's supergravity. So the supergravity causes the other particles to have regular gravity. It causes, it's just circular bullshit.
Photon, or whether it be one step below it. If electron, what we call an electron, is orbiting, then in our model, for instance, we'll say there's a field below that. It's a gravitic random field that's making it go. It's a different particle. It's got to be a different particle. And you can keep going and going and going. But
so there's no such thing as charge, but there's some sort of thing called gravitic. Okay, so it just happens to go towards something for no reason. No explained reason why there's this field of gravity. Where does it come from? What makes it? How does it emerge? It doesn't have any of that. It's just magic.
what I'm saying is, yeah, I mean, you have to. And I think the idea is that I think people have been around in the distant world for so long. And I heard these things for decades. Fields, dipoles, magnetic fields. Oh, a charge and a moving charge in a field. And I'm thinking the answer isn't the charge or the moving charge. The answer is, what's your model for these things? And that's what happens. So in our model, for instance,
yes, their model sucks. Your model sucks. Doesn't work. Okay, your swirly model of swirly is just as bad as their virtual photon.
we'll tell you, right or wrong. We're not saying we're right.
Oh, yes, you are. And why would you bother then? If you don't think you're right, why would you even say it? So obviously you think you're right, So what's the difference? You're saying it, and it's pretty certain that you think you're right. So why are you saying, well, we're not saying we're right? Well, that's pretty much the way you say you're right, is when you think it and then you say it.
But we have that. And I think one of the things our model we're trying to push out into the world is like, okay, folks, right or wrong, we're gonna have a physicality for every time you ask a question. We're going to tell you what physically is there. So if you say, okay, you're saying that
infinite Hoobies did it. Okay. Oh, that's better than infinite gremlins. Oh, sure.
an electron bends, well, how come you have to tell me it bends? Well, yeah, we do. It's a gravitic field below it. It goes faster than the speed of light. Okay. Oh, then if those bend, well, there's a gravitic field below that. If there's people that realize there's models that can do it, right or wrong. Right or wrong. I mean, my friend said,
if they can do it, then we should demonstrate that they have that they also work. But again, you haven't demonstrated. You can't draw a picture of your mush, your magic graphitic fields from infinity.
Unimaginably small amount of time, it stops. That's the only way they could get a uniform universe. So, like dark matter and dark energy, what they've done is say, hey, we have a model, but the empirical evidence doesn't support our model.
What's the point of this? Yes, I'm going to video my, whatever this room would be, the flower room, I guess. Must have some money, I guess, to have flowers.
So what we have to do is, it's like solving a math problem. How do I get the empirical evidence to match my theory? And they do it by creating dark fudge factors, which are those. Now,
yes, this is a very easy target, dark matter, right? But there's more important targets right in front of you. Oh, I'm just saying that, what's more important? 1/2 mv squared, which is used everywhere. I mean, it's everywhere. Or dark matter, which who cares, whatever. Who cares about, we have to make the galaxy spin a little faster, so we need dark matter. I mean, it's just such a nothing part of physics compared to this elemental part that they fucked up. So you ought to pay attention to the elemental one they fucked up. light being bent by gravity. Big elemental fuck up. Okay, 1/2 mv squared, big elemental fuck up.
I wouldn't mind it if they say, hey, this dark matter, we have no.
All right.
The symbology gives me some kinds of relationships of being able to calculate. All of a sudden, to when I throw the philosophy of you can't go faster than the speed of light and all frames have the same physics, all of a sudden I get these bizarre mathematical conclusions that time dilates, mass increases, and what's the other one?
There's effects in the universe. So clearly, you look at time dilation, you're saying, what clock are you dilating? Every clock breaks a different way. So yes, velocity disrupts atomic decay of isotopes. The isotopes decay at a different rate based on how much you're moving them. But they decay at a different rate based on how much you heat them. Based on a lot of things. A lot of things disrupt atomic decay. Change it.
Contraction. So I mean, aren't those really in special relativity those things? I mean, we're getting ahead on math, but that's okay. Aren't those things in special relativity truly vestiges of us getting caught in math and going down fantasy land?
No, we're not caught in the math.
So-
We're just being shielded from what they're saying by the complexity of the math. The math is saying something, but it could be just like Einstein's field equations could just be saying, the sun's precessing, and because the sun is precessing, wobbling, Mercury feels it because Mercury's really close, and everything else doesn't feel it so much, so it doesn't get bothered by it very much. So it's not as statistically important. But it's statistically important to Mercury that the sun, it just isn't staying exactly in one place. And all his field equations could just be doing that, but we can't tell because they're so convoluted. We can't tell what they're really saying.
What that really means is, unfortunately, the most famous equation in physics, in my opinion, is somewhat useless because it's not, without a model, you don't know what's going on. And if you look at it with today's models, most people who are in the newer models in the last 5 years are going to say, it's sort of like non-interesting. I'm not interested in E equals mc squared. What I'm interested in is how the universe.
Well, I think it's pretty interesting to recognize that what basically is happening is atomic systems store energy. And that's really where the E equals mc squared comes from. The mass is relevant only when it stores energy. So if I put one electron in space, it doesn't have any energy. Okay, it just doesn't. It's mass and it just doesn't. But if I put 4 electrons in space, well then I can capture energy. Okay, that just doesn't go anywhere. It's stuck inside the matter. So now it's inside, essentially, the matter. So now 4 electrons means yes, okay, there's a lot of energy, and it's completely related to the mass of the electrons in the sense that there can't be too much energy or the electrons will fly out. So it has to be just enough. It has to be balanced by protons in the middle, and so that relationship is going to decide how much energy you can store. But the fact is you can store a lot of energy between material objects. But yes, it's not in the objects themselves. The real elements of mass don't have any energy. But the fact is you can arrange the elements of mass where they trap energy. And so now a lot of energy can be there. But there's no standard amount. It really doesn't equal. You don't take any 4 electrons and say they have exactly this much energy. 4 electrons, this much energy. No, just like a battery. You can fill it with energy. Okay, it changes. It doesn't have the same exact amount of energy.
Works. What are these things we call light, gravity, electricity, magnetism?
Oh, there's
And,
Franklin.
I don't care about energy. The word had something to say about energy, and the saying that had something to do with movement. It says, here we go. Energy says, I don't care. Now that, but this is good. I don't even know. That's pretty funny, actually. But being like, I don't care. Well, I guess the way I would say, Sandy, is energy doesn't exist. It's a fantasy. So you can say fantasies can talk. So there you go. So energy doesn't care. But I do like your idea of movement. That I think is, I would say that's closer to it. And of course, if you're Borkert, movement is time. So but I think that's an interesting point. Anybody else?
Duh. Oh, I mean, duh. I mean, duh.
Just want to talk about energy? Is that all you had
I
there?
think it's also like Bob was saying, kind of an operational thing. I think it's okay in science to do those kind of operational things. So I can understand that you think that if you can't explain what charge is, that's poetry. In which case, yeah, everybody practically is doing science poetry, but that doesn't preclude you from doing useful work. So
Okay, I understand what you're saying. I will push back on that, like I did push back before. It's different to say science. Science poetry to me is words without physicality. And there's two things I would say. So to say that, for instance, labeling a particle a G1 particle is poetry, it's not. You're labeling something that's physical, right? The second thing is that
but wouldn't you need to find that? I mean, I'm perfectly fine with having particles, but I don't know if mainstream science has found a G1. So is that poetry? Or
no, because to me, what it is that if you can't explain the physicality, you've got to call it something. We can call the particle this, right? We're talking about this particle in our.
So let's understand his G1 thingy is both electrons, photons, it's all kinds of stuff. It's the same thing. So it just doesn't make any fucking sense.
Model that does these four things, okay? Now, we have to label it. We can call it Fred, all right? We can call it Fred. Now that, yeah, there's a difference between, I think, labeling and science poetry, which what I would call science poetry. I think that what James would call science poetry. I think what Nick was calling science poetry, are using words with having no idea what they are. For instance, you were saying dark matter, right?
Well, you need to bring in the experiments, for example. I think maybe that might be a distinguisher between science poetry and, I don't know, real science. So, like, we have experiments, people, I see we have Dr. Lucas here working on accelerators, and they find, like, all these different particles, they find mesons and
Claim to find
electrons and all these other exotic things, and we can make beams out of them. So those are experiments. So what I'm asking you is that, you have G1, which is not any of these known particles, right? And so...
Wait a minute. A G1 takes the place of a photon, electron, and a graviton. So...
yeah, so it's complete mush because these are obviously rabbits, buffaloes and elephants, and there's just no way we just come up with one word and call them elephants. Yeah, there's just no point in that. That's too stupid. You don't call them all elephant. No.
You can call it electron if you want. If it's when it's going around.
Oh, thank you.
You can call it you can't call it a photon because a photon is not what we have. But again, it doesn't matter. Let's throw away our motto. When you look at something, if you have a physical thing, you got to label it. That's
throw away your model. Yes, let's do that. Let's throw it away. Jesus.
They won't admit that. They would throw it out. So. Okay, I'm going to take you down, but thank you so much for that conversation. Anybody else want to talk about energy?
He shut him
in the
up.
green room or make a comment there?
Let's see what kind of loony he has in here. Oh, he's old
develop
man.
Vestiges and things that aren't real in the physical world, and we'll get all hung up on them, like with relativity, for instance. Maybe dipoles are the result of people not having a model for magnetism and just looking at the mathematics of it or the symbology of it.
There is one. I believe water is a electric dipole.
I don't know. Does somebody come on and explain what a dipole is? Now, I don't know physically they can, but at least in a magnetic sense.
Yeah, it's having the charge thing that you don't think exists. There's electrons and protons, and when they're not evenly distributed, that is in some circle where there's positive in the middle and electrons on the outside, when there's not an even distribution of their access to the external world. That is, when you look at it from this side, it looks more red, and it looks more blue from this side. That's a dipole. Yeah. Okay. Dipole just means polar. Just means it has poles. Alright, anyway. So, we're done, right? Yes, I'm done. I'm fatigued enough. Ugh. God. Just gotta endeavor to persevere, Gary. Endeavor to persevere. I can't even you can't even envision some sort of way out. It's like I'm getting so distant from any notion of not being, not drowning in a cesspool. I can't even imagine fresh air. I can't even imagine the sunlight anymore. It's getting so deep, the shit we're in. It's just such deep shit. It's like, we're really not going to get out of this, are we? No. We're going to be suffocated in shit. right to your last day, you're just gonna have to breathe this shit. Not even a moment. One last gulp of fresh air. No. It's gone forever. That's poetry. Yeah. So anyway, till the next time and such. Wasn't much fun, I have to say. I really didn't have any fun at all. So this has been the DraftScience video presentation, brought to you by all the fine people in my basement.